Hello and welcome to part 2 of the Writing FreeDOS Programs in C. This is the weekly video series where I'm going to teach you about writing your own FreeDOS programs in the C programming language. So just to kind of talk a little bit about what my environment looks like, I'm going to be doing everything in FreeDOS. And you can do FreeDOS and follow along. If you are a Linux user, you can also compile everything under Linux. C is very cross-platform. In fact, it started on Unix systems. If you're a Windows user, there's also Cygwin that you can use as well. But here I've got a FreeDOS 1.3 RC2, and it's a base install, but I've installed a couple of extra packages. Under development, I've got DJGPP, and that's the environment for the DJGPP compiler. But I've installed the IA16 version of GCC. IA16, by the way, just means it's a 16-bit version of the compiler. I've installed all the packages except the source code, because source code, you don't need the source code to compile. And even though we're not going to be using it right now, I've also installed OpenWacom. That's another C compiler, very popular C compiler, but I'm going to be using the IA16 version of GCC. Now for editing, you can use really any editor that you want. I've installed the Fed editor, the folding editor, because that will colorize the source code. And I think that makes it a little bit easier to follow along. So let's go ahead and get started. So as we do this, I'm doing everything in source. As we do this, I'm going to be walking you through various things in C programming. We're going to walk our way up to things. So if you don't see something right away that you recognize, if you do know a little bit of C already, if you don't see something right away, we will cover it. First of all, one other thing on environment is you need to have DJGPP as your environment variable set, and you're also going to see me type ls. And that's not a new command. That's actually, if I type alias, that's just an alias to the FreeDOS dir command with some options that make it look like the Unix version of ls. In case you're curious what that is, /w is a wide directory, /b makes it a bare. It's not going to print any heading and footing information. /l makes it lowercase, and then we're going to order everything by grouping directories first, and then we're going to sort by name and then extension. And so that's what ls is giving me. So let's go ahead and start with our first program just to learn about what is the anatomy of a C program. So let's go ahead and type fed, and we'll just do a simple hello world. Most programmers, when they're learning a new language, they will start with a hello world program just to learn about what it'll do. Let me type in a program first, then we'll talk about it. So we're going to put in a comment. We'll just say hello.c. That's our comment, and then we're going to do include standard.io.h. Now, if you have seen other programming videos that I've done, you always know that every C program will start with an include standard.io.h, and then we're going to do int main. And then inside these curly brackets, we're going to actually type our program, and we're going to do put s, which is the put string, and we're going to put the string hello world back to the user. And then we're done, so we're going to go ahead and do return 0. So let's go ahead and talk about what I've typed in here. Let's start right at the top. So C has comments, and you're going to start a comment with /star. And you're going to end a comment with //. You can also, by the way, do it as not /star, but you can do // right? That's the same thing. But I prefer to use the /star. You can actually nest comments, but be very careful about what you're doing. So you'll note that I could actually do /star, and that is still a comment. Now, one thing I like about Fed is it colorizes the code. So you can see anything that's in this blue is still a comment. And so the C compiler will say, oh, hey, I found /star. Now, white space isn't really important. So the fact that on the next line it starts with another /star, it says that's still part of a comment. I'm going to keep going. And then it's going to say, oh, over here I found a // That's the end of a comment. So if you nest comments, you really can't nest them, like both of those sides, because another /* is going to be something else, because it's already found the end of the comment up here, and so another /* would or // would give you an error. So that's something about comments. And comments can appear anywhere, and they're useful to you to keep track of what you're doing. If you're writing a long program, it's a great idea to include some comments so you know what's going on. The compiler will just completely ignore everything in those comments. Here I have an include statement. So what's going on with include? Well, includes, it's going to include at the compile time. The compiler is going to, there's a file in the system called standardIO.h. And it's going to include this file so that way the compiler knows everything that's inside standardIO.h. Without going too deep onto this one, because you don't need to know the depths on this one, every function that you call needs to be defined in some way so the compiler knows what's going on. Anything that's going to be in the standard C library that prints things to the screen or reads things from the user, that's called input-output. And so it's IO is because it's input-output. And in fact, the putS function is standard IO function. It's output. And it's part of the standard C library, so you're going to see std. Here I've got int. And that is one of the variable types that C supports. We'll talk about that in a second, but you can support, there are different types of variables in C. Integer is one of them, and the name for that is int. And then main, that's the name of the function that I'm writing here, but main is a special function in that every program has to have a main function. This is actually where the guts of the program actually happens. And I've included here parentheses because you would give parameters, usually variables, values of some kind, you'd pass to a function by enclosing them in these parentheses. We're going to fill out the main function in a later exercise, but for right now, we're going to for today we're going to use just an open and close parentheses, and that'll be how we're going to define our main function. How does the compiler know where the main function begins and ends? Well, it begins with this open curly brace, and it ends with this closed curly brace. Now, I'll say that white space is mostly unimportant to the compiler, and so I could have put the open curly brace up here, and in fact, some programmers will do that. I don't have to have these next lines indented. I could have them at the beginning of the line. That's totally fine as well. The compiler won't mind that. And I could even put the closing curly brace over here. That's perfectly valid. In fact, I could even put all of my program on one line, and that will compile just fine. Now, the compiler doesn't mind that. But you as a human would probably find that hard to read. So I like to have my open and close curly braces on their own line. And that makes it easier to see what's going on. I like to indent everything so that way I know what's inside the main function. As we get into loops and if statements and things like that, we'll see other uses for those curly braces. And I will indent things inside there as well. So this is the easiest way that I find to read programs. Now, by the way, you'll find different ways that people will what's called indenting programs with how many spaces they use, or if they use tabs and spaces. That's the big war, right? But here it doesn't matter. PutS is a function. Getting back to the end of the program, putS is a function, and it knows that because there's an open parenthesis. And so it says, all right, putS is a function. It also had that definition for putS in the standard IO, what's called a header file. So inside these parentheses, the C compiler will say, okay, what am I passing to the putS function? I'm passing it a string. Strings begin and end with those double quotes. and the reason I use the Fed editor is because it helps to colorize the code. You can kind of see what's going on. And strings in here are kind of in this brown color. The function call ends with this close parenthesis, and then semicolon is actually ends the statement. That's how the compiler knows that statement is done. Now I'm ready for the next statement. And the next statement is a return, and that's a keyword that in C, and it's going to return a certain value. Functions always would do, well, they don't need to, but usually they're going to have a return statement of some kind, because main is just another function, you can exit the function with return. Now, main over here was defined as an integer, and so we need to return an integer, and 0 is the integer that we're returning. Typically, programs will return a value back to the operating system to let people know what happened. 0 is a very common code to indicate that things went well, and then positive integers would be would indicate different types of errors. So 1, 2, 3, things like that. On DOS, by the way, that's called an error level value that gets returned. And then we're ending our statement with semicolon, and then again, the compiler has seen the end of the main program, and now we know we're done. So let's go ahead and compile that. We'll do a save and quit. And let's go ahead and compile. So our compiler is the i16 GCC. And we can just call hello.c. And now it will compile the hello.c program. Now, it's not going to create, because we're using the GCC, it's not going to actually create a hello.exe. It's actually going to create an a.out file, because we didn't actually tell it how to name the output file. So let's go ahead and get rid of a.out. And let's go ahead and recompile using i16 GCC, but we're going to tell it use the output file -o hello.exe. And then what do we want to compile? Hello.c. And now it'll compile that. And then we now have our hello.exe, which now we can run our own program, hello. And it prints out the string hello, hello world. Let's go ahead and get rid of hello.exe. And let's do one more compile. I like to usually compile using by turning on all warnings. And you can do that with the -W. And what warnings do I want to have it print out? Well, you can give different options here, but you can just say the word all, and that will give all warnings. So if I did something wrong, or if I made a small error, this will let me know. And again, I want to print it to the output file of hello.exe, and I want to compile hello.c. And then there's my hello.exe. Prints out hello world. And so now that's our first program. So let's learn a little bit more about variables. So let's do another one. This is going to calculate a little bit of math. So let's go ahead and do, let's call it math.c. So we're going to start with our include standard io.h. And then our main function. Now again, white space is unimportant. I could put int main all in one line. Some people do. I prefer to have that on separate lines. Now, this is where we need to tell the C compiler that we have different variables. I want to do simple division on this. We're going to have a value on top divided by a value on bottom. I need to store that result somewhere. So I need to tell it that I've got a variable called top. But what kind of variable is it? Well, I need to tell the compiler that. And so I say, okay, int. The name of my variable, or the type of my variable top is an integer. Semicolon, because I'm done with that line. And I want to do the bottom. And then when I'm done calculating that, I need to have the results. So we're going to do int result. And so let's go ahead and store some values. By the way, we're going to have different types of variables here in a second, but just briefly, there are different types of variables you can have. One of them is an integer. And those are going to be whole numbers, things like 0, 1, and 2. Also -1, -2. You can also have a variable type that's a float. That's a floating point value. So floating point values are things that have a decimal in them. So 1.1, 2.5, things like that. That's a floating point value. Also negative numbers, -5.3, things like that. Similar to an integer is a thing called a char. And we'll talk about that later on, and that is a character value. It's very similar to an int, but it stores smaller numbers than an int. And another type of variable is a double, and that's very similar to a floating point value. In fact, it is a floating point value. It just can store, as you might guess, twice as big numbers as float. But I don't need what I've just typed in, so I'll go ahead and start something else. Let's go ahead and now store some values in these variables. So let's store the value into top, the number 25. And so what I've done here to store that variable, that value, is I've said, okay, this is the name of the variable that I want the value to go into. Equals, single equal sign will say, okay, store store a value in here, and then 25, a number. And that's what is now going to be stored into the variable top. Bottom is going to be 5. And so I'm going to divide 25 into 5, right? 25 divided by 5. And that's what I want to do here. Is I want to now do a calculation on that. So the result is going to be the top divided by bottom. Now, there are different types of operations you can do. You can do addition, subtraction, multiplication with the star, and then division with the slash. Those are your basic types. You can also enclose things in these parentheses. And the way that C operates is that it will look at the parentheses first, and it'll do stuff inside the parentheses. And then it'll first do multiplication and division. And it'll then do addition and subtraction. So let's go ahead and print this value. So we're going to, we could do a put s, right? Put s will put a string onto the screen. That's what put s stands for. And so I could say the result, right? But I want to print out the result. How do I print out the result? Well, put s will only put out a string. Result is a number. So I want to use a different function. And that function is a formatted print statement. And the name of that is printf. So it will print, it will print a formatted value, printf. So I need to give it a format string. And that'll go inside these double quotes. I filled that in. Let's go ahead and fill that in. So I want to just print out top divided by bottom equals the result. Let's actually just print that to the screen. Well, I can't just type top because that's just a string. So printf will look for certain codes in this format string. And the way that it'll spot a variable, placeholder for a variable, is %. And so %d is a decimal value, so an integer value. I'll put full information about the types of these codes that you can have in printf in the programming guide. So if you're in the Patreon, you'll be able to see that. Actually, I'm making this part as well for free to everybody. So you'll see this in the programming guide on the website. Divided by, so that's just going to print out a space / space. And then I want to print out another number. So %d is going to be another integer value, and then equals. And then I want to print out another number, which is %d. And so what's going to happen here? Well, printf is going to see, okay, %, and then d is going to say, okay, I'm going to put a variable there, and that's going to be a decimal value, or more specifically, it's going to be an integer value. This other stuff is just text. It'll print that to the screen. And it says, oh, I found another %, and then a D, so it's going to put in another integer value here. And then the space equals space is just text. It'll just print that out to the screen. And then it found another %D, and it'll print out another variable. We'll talk about the other things you can put in here. If you want to, for example, print an actual % sign, you want %%. But here I want to do another number, so %. So let's go ahead and put in our top, bottom, and result. You'll note that I've the way that you call printf is you're giving it a format string, and then you're giving it a comma, and then all the variables that you mentioned in the format string have to be listed next, and they're going to be listed in order. So top is this first variable over here, and then bottom is this next one, and then this last placeholder for a variable is result, and that's how it's going to print it out. Top / bottom equals. And now we're done with the program, so we go ahead and return 0. Oops. And let's go ahead and save and quit. i16 GCC. We turn on all warnings. We're going to output into math.c. math.exe, and we're going to compile the program math. And no warnings on that, so we'll go ahead and do math, and it will print out 25 divided by 5 equals 5. Now, what if it's not a whole number that I'm actually dividing? I mean, 25 divided by 5 divides very neatly into 5. But what if I had a remainder to calculate? So let's go ahead and do math.c. And so I need to, if I had a remainder in there, int remain is what we'll do here. And now let's go ahead and calculate the remainder. So I'll calculate the results. So how do you calculate the remainder? Well, remain, you're going to need to multiply the result that you had, result, times the bottom, right? And then you need to subtract that from the value on top. And so that would calculate the remainder. That's the way that you would just calculate that through arithmetic. Now, again, multiplication and division happen first, and then subtraction. So it will multiply result times the bottom, and then subtract that from top. For clarity, I like to include parentheses. You don't need them here, but I like to use them. So there we go. Top equals result times bottom. And then we're going to indicate over here remainder of %d. That's a variable we need to put in there, and that's the remainder. All right, let's go ahead and save that. And we recompile. Go ahead and delete math.exe. Turns out you don't actually need to delete math.exe. It will recompile over top of it with this command line. So just to show you that we're recompiling it. And now math gives us the remainder. Now there's another way that you can actually calculate remainder. Let's do that real quick. Math.c. So this is using arithmetic. Let's put that in here. Using arithmetic. Another way that you could do that is you would calculate the remainder by doing what's called modulo. Modulo is an operator that actually just literally gives you the remainder after division is done. So instead of using a slash, we're going to use %. That's the modulo operator. So top modulo bottom gives you the remainder. And now we're going to print out put s using modulo. And now we're going to printf, rather than type this whole thing, let's actually copy and paste that down there. So copy And oh, end of our program. Save and quit. Let's go ahead and delete math.exe. Again, you don't have to, but just so we know that it's actually been deleted. And we're going to go ahead and recompile using GCC. And no warning, so we know it worked. So math 25 divided by 5 equals 5 with a remainder of 0. Now, there's something interesting here that I wanted to point out, which is that the using modulo string, the putS value, got smushed up next to the output line from up above. So why is that? Well, that's because printf needs you to tell it when to insert these new lines. So putS will automatically print a new line, will basically go to the next line, literally, after it's done printing the string. That's what putS will do. Printf will not, because you get to insert those wherever you want to put them. And so the way that you tell printf that it's ready to print out the next line is to use a special code, and that's \n. There's a couple other ones in there, and that'll be in the programming guide. But printf will see the \, and it'll actually insert a new line that gets printed out to the screen. And I'll put that down here. Now, the reason that the DOS prompt was on its own line is because DOS will do that by itself. But inside the program, you actually need to, if you're using printf, you need to put in the new lines on your own. Let's go ahead and now save and quit. We're going to recompile our program. I didn't delete math.exe this time. We'll just let it overwrite the program. Oops, math. And there it is. It's 25 divided by 5 equals 5 with a remainder of 0. Now, if I do other values in there, so 26 divided by 0, always test your programs. 26 divided by, sorry, not by 0, 26 divided by 5 should give you 5 with a remainder of 1. Save and quit. There we go. And then 26 divided by 5 is 5 with a remainder of 1. Right? So there you go. That's the correct way to do that. Now let's do another program that will mix integers and another type of a variable, which is the floating point. I mentioned float. So let's go ahead and do that. We're going to do a program called circle. And I'm going to just go ahead and do this right away as a using floating point values. So we're going to do include standard io.h. The programming guide, by the way, will include a different version of this program that also uses integers. But we're going to do this one with floating points. So we're going to do int main. And then how do I tell it again that I want to have a floating point variable? The name float. And so we're going to calculate, this is a circle, so we're going to calculate the perimeter and area of a circle. So in order to calculate that, I need to have the radius. So there's our radius. And I'm going to calculate the perimeter, and I'm going to calculate the area. Now, one other thing I'll mention on here is that I've defined all of my variables each on their own line. And that's a great way to do that. And if you want to kind of keep your programs easy to read, that's not a bad way to do it. But if you've got several different variables that are of the same type, I could get rid of this line here and I could do comma area. And so that would work as well. That would now define two different variables, perim and area, that are of both type of float. And down here, I could now insert a value into radius. Let's say the radius would be 16, but 16 by itself is an integer value. I want to make sure this is a floating point value, I need to give it 16.0. So I could do that here, but if all I'm doing is defining the variable, and then before my program does anything, I just assign a value to the variable, I actually don't need to do that. I can do it all in one step. So let's get rid of that line. And then up here, I could say float radius equals 16.0. And so now what that's done is that tells the compiler, hey, I've got a variable that's a floating point value, float. The name of it is radius. And you're going to insert a value into it. And we're going to insert the value of 16.0. So that's what it's seeing. So let's go ahead and now calculate the perimeter. So how do you calculate the perimeter? Well, if you remember that, it's 2 pi r. So 2.0, because that's going to be a floating point. And then pi. Anybody remember pi? It's 3.141. That's a simple representation of pi times the radius. And the area. How do I calculate the area? Well, that's pi r squared. So 3.141 times radius. And there's no squared operator, so let's do radius a second time. So radius times radius is radius squared. And let's go ahead and print out my my results. So I can't use putS because that would just print out a string. So again, I want to use printf, print out a format. And so I want to print out the, I'll say, perimeter of a circle of radius equals a floating point value. So %d would have given me an integer value. %f will give me a floating point value. Is %f, another floating point value. And then a new line. All right, so in order, I wanted to give it the radius of the circle first. So radius, and then comma, and I want to give it the perimeter, the result, right? So perim. And I want to close my function and a semicolon, and let's go ahead and print out area of a circle of r equals %f is, what's the radius? The floating point value, so %f. There's my new line. There's my radius. There's area. Let's make this look a little bit nicer. Let's go ahead and just add a little spaces so that words kind of line up. All right. And now I'm done with my program, so I can go ahead and return 0. All right. Let's go ahead and save and quit. i16 GCC, that's the compiler. We're going to turn on all warnings just in case. I want to save my output into circle.exe, and we're going to compile circle.c. All right. And aha, this is why you use all warnings. So it's caught an error, and I misspelled radius is really what it is, because it found an undeclared variable called radius because I misspelled it. So let's go ahead and go back into circle.c, and there is my radius. Oops. Go ahead and save and quit, and we're going to rerun the compiler. There we go, and now we run circle, and you can see that the perimeter of a circle of radius of 16 is 100.512. The area of the circle of radius 16 is 804.096. Now, that's a great way to calculate using floating point values, but you'll notice I used pi a couple of different times. So let's go back into that circle.c. And so I've used pi on 2 different lines. And if you're going to be using a number all the time, it's great to actually have the compiler know about that number and just sort of have a placeholder for that number, so that rather than typing in 3.141 all the time, I might actually just hold on to as a placeholder called pi. And then down here, again, pi. Well, how do you define that placeholder? The key is kind of in the name. It could be a variable, absolutely could be a variable, but in this case, we're going to define it as what's called a define, the constant. So we're going to say define up here, pound define. And what I want to define pi. And these constants are usually all uppercase. So the fact that I've done it as capital P, capital I, that's very typical. You could do it lowercase p, lowercase I. You're going to easily confuse that as a variable. So just typically you'd use all caps for your constants. And then you could put in 3.1 for 1. Or if you're like me, you actually know the full number for pi, or at least more digits of it, and 3.1 for 1, 5926535. And no, I'm not actually looking that up. I actually know that. Now, I'm not putting in a semicolon at the end, because what's happening is we've told the compiler, hey, I've got a definition for you. Anytime you see pi, put in everything that follows, literally in there. And that's important if you're going to be doing, I'll call them macros, but they are called macros, but as a constant, it's going to literally, where it sees pi, the compiler is going to say, oh, okay, I can actually insert 3.1 for 1, 5926535. I'm going to insert that there. And down here where it sees pi, it says, oh, I know that's a constant, so I'm going to go ahead and put in the variable for, or the value for the full number for pi. And so that way I don't have to keep retyping that number all the time. And especially if you're typing in a long number like I just did, if I had to type that number in all the time, I might mistype a number at some point. This way, I define it once, use it multiple times, and I'm done. So let's go ahead and save and quit. And we're going to recompile using the GCC, turning on all warnings. Output is circle.exe, and we're compiling circle.c. And now if I run circle, I get a much better definition of my number because I've used more digits behind pi. So that's why we're seeing more digits there. And so that's how you'd use a definition to create a symbolic constant. And that's how you would use a floating point value. Now, there's quite a lot there, but what if I wanted to, I'll show one other thing. What if I didn't want to just keep hard coding the values all the time? What if I actually wanted to read a number to calculate the area and the perimeter based on some number that the user gives me? Well, one way that you can do that, let's go ahead and go back into circle.c. One way that you can do that is, rather than assigning a value up here, we'll just go ahead and clear that out. So let's go ahead and add in some new lines. Let's add in a section here where we're going to read a value. So putting in a comment, and then down here, this is the calculated value. Calculate the results. So let's go ahead and read my value. I probably should print a prompt to my user. So put s. I'm going to go ahead and put a string out on the screen. And we'll say, okay, enter the radius. And then I want to read a value from the user. Now, just like printf was printing to the screen using a format string, you can actually read data that way as well. We're going to talk much later about better ways to read values from the user, but for right now, we're going to just very simply do a scanf that will scan a value using a formatted string. What do we want to read? We want to read in a floating point value. And then I want to read that into the variable called radius. Now, we're going to talk about pointers and references several weeks from now. But for right now, all you need to know is that when you use scanf, rather than using the name of the variable, you need to put an ampersand right in front of it. From a technical perspective, that gives it the address that's needed by scanf. But whenever you do scanf, you need to have that ampersand in there. Everything else remains the same. all we've done is now present a prompt to the user and ask them to enter in a radius. And then it's going to calculate the perimeter and area and print that out to the user. Go ahead and save and quit. And we're going to go ahead and recompile one more time. And so now when I run circle, it's going to prompt me, oh, hey, let's go ahead and enter the radius. Well, if I enter 16, I get the same number I did before. But I could also do a radius of 12. I could do a radius of 1, right? That's an interesting thing to do, right? The unit circle, right? So that'll actually help me test the results, right? Because the area of a circle is pi r squared. 1 squared, the radius is 1, so 1 squared is still 1, so I should be getting pi, 3.141,593. And 2 pi r is the perimeter of the circle, so it's twice pi is the perimeter. Another way that you can actually do that is by saying 0.5 is my radius. And now 2 pi r being the perimeter of the circle, well, twice 0.5 is 1, and so that gives me the value of pi. So 2 pi r is pi if the radius is 0.5. And so that's given us a brief introduction to how do we declare different types of variables, what a program looks like in terms of its outline, different types of variables that we have, different ways to operate on those variables with the different arithmetic operators. We've learned about put s, we've learned about put f, we've learned about scan f, and we've learned about symbolic constants. And I think there we'll stop. And join me again next time. We talk about more things that you can do inside C. We're going to learn about flow control, about if and else, and some loops and things like that. Before I go, I just want to say thank you to my Patreon supporters. You really do make this series happen. Several of you have donated at a higher level, and I just wanted to thank you here in a special card. And that's it for this week. So what else? What do you think about this series? You can leave your thoughts below in the comments. You can also visit our website at freedos.org. Follow us on Twitter, join us on Facebook, and consider supporting me on Patreon. Thank you.